fully charged. That means what I can say? The energy stored by the capacitor will reaches to a maximum value. Energy stored by the capacitor will reaches to a maximum value, not in maximum value, that the capacity of the inductor is over now. That means what happens now here, the capacitor inductor fully charged. In fully charged condition, we can call that as a steady state, isn't it? In steady state, the fully charged inductor is capacity of the inductor fully changed, completely over. Then what I can say, inductor fully charged, then I can write as what now here, the inductor, then inductor fully charged, I can say. If it is fully energized, fully charged, means what I can say, if it is fully charged, fully energized, means what we can say from that, its capacity is over already. That means inductor will be reaches to a steady state. Yes, in steady state, how this inductor will behave as a short circuit. In steady state, how this inductor will behave as a short circuit. Understood this thing? At t is equal to 0, switch is what now opened. Before what happens, switch now closed. Before means, what the meaning of before is a till t is equal to 0 minus, till t is equal to 0 minus, I can say this is what I can say, t is equal to 0. At t is equal to 0, it is something. Yes, from where? From minus infinite to yes, up to here. That is what it is, till t is equal to 0 minus now, up to before that. So we are giving the energy we are given to inductor, we are continuously giving or not. So the inductor will be fully charged. The fully charged means the capacity, it will be over or not. So then we can call that as what, a steady state. In steady state, the inductor will behave as what? Short circuit. In steady state, capacitor will behave, inductor will behave as what? Short circuit, I can say. Right. Now let us redraw this network now here. Then if I redraw this network now with a short circuit, yes, here we have one resistor, switch is closed now. And what happened? Inductor will be like a short circuit only. And here is a resistor. And how much this current is in? 2 amperes. And this is 30 ohms now. And here the switch is closed. Inductor, it will behave like a short circuit only now. I can say this as IL of 0 minus. And I can, this voltage is a, we need to get this thing here. And here this is grounded now here. Now see this thing here, what happens now. Now this current, this is the current to inductor, IL of 0 minus. Yes, this is a current to inductor before the switching action now. How much this current is now here? Now this current is 2, yes, and here we have shorted path is there now. The complete current will go 0 only to here. Again here we have shorted path is there now, complete current will go 0 only, and this current is 0, and this current is how much? 0. Then what we can say now here, this current which is equal to, the complete current will goes in this path only now. So IL of 0 minus is how much it is? 2 amperes. IL of 0 minus is how much it is? 2 amperes, isn't it? So they ask me to find IL of 0 minus now here. So how much this value I can say right now here? This is the 2 amperes. Next, V of 0 plus means what? Voltage across this element at T is equal to 0 plus I want. Now, let us draw this network at T is equal to 0 plus I can say. What is the T is equal to 0 plus is at? When I did a switching action at T is equal to 0, at T is equal to 0 minus is just before switching action, at T is equal to 0 plus. 0 plus means what it is immediately after switching action. T is equal to 0 plus, this is immediately after switching action. Immediately after switching action means we are not giving energy. Suddenly we have started giving the energy at T is equal to 0 onwards. Immediately after switching action means what now here? The inductor will be take some time to adjust now here. And the adjusting, that nature we can call it as what? Transient situation we can say. Then from this what I can say now here? At T is equal to 0 minus, this I can call it as I plus, this I can call it as what? Transient state. This is the inductor is in the transient state now, isn't it? Can I draw this network at T is equal to 0 plus now here? And what I'm going to switch now here? Switch is closed or opened? Switch is closed or open? Switch is open now here. And here this inductor, this current is what now? 2 amperes. And this is 30. The switch is open now here. And here we have inductor. This inductor, how this inductor will behave? Inductor will behave like a in transient state. Inductor will behave as what? Open circuit now. Open circuit, but what is the equivalent circuit of inductor is? It always have a equivalent circuit is of inductor is what? We have seen a equivalent circuit of inductor. Inductor equivalent circuit is like this now. It always have what it has? Parallel initial current. It has what? Parallel initial current. But inductor is open and it has a parallel initial current is like this I can say. Then so this complete current will go zero only na. Here 2 amperes of current will go zero only. A switch is open na. Here this is the ground. And how much this current is at 2 amperes, and this kind will goes here, this kind will goes like this now. How much this resistance is at 20, and they ask me to find this voltage now. I can say this as V of 0 plus I can say at T is equal to 0 plus a network. So then how much this V of 0 plus now here? V of 0 plus is how much it is? This is the 2 amperes. So this is 40 volts now, plus 40 or minus 40? Plus 40, isn't it? This thing. This is a V of 0 plus. That's what they asked me to find now. So this is how much it is? 40 volts. Next, what else we should find now? IL of T. What is the IL of T? Is the current to the inductor general expression now. General expression. Even you can see here. Previously we got IL of 0 minus, we got 2 now, and you can see how much is IL of 0 plus I can say here. Yes, this current I can say IL of 0 plus I can say now. How much is IL of 0 plus is it? 2 only. As we know, as we have seen, IL of 0 plus which is equal to what? IL of 0 minus only now. Inductor does not allow sudden changes of current, so that's why same thing. Yes, we already seen this thing. Inductor does not allow sudden changes of current, right? Now, now let us find IL of t, general expression. For this thing, what we should do here, we need to find what is the formula we have seen. I want to find what now here? IL of t. What is IL of t? I can say now here. What? Final value plus what? Initial value minus final value into e power minus t by tau. Now see the terms, each term here. Final value means what I can say if I say IL of t. Final value means what I can say? IL of infinity. Plus initial value means what now here? IL of 0 plus minus final value means what? IL of infinity into e power minus t by tau. What the tau is? Time constant. What's a tau is? Time constant. Time constant for what type of network it is? RL or RC? RL network na? For RL network, time constant which is given as what? L by R for RL network na? So let us find out each and everything in this thing here to get this thing. There what are things we should know here? First of all, IL of infinity we need. What is IL of infinity is a? Now if we see in these cases and this current, the supply current completely always flows in this path only now, and this supply current doesn't come into this inductor in this path here. So inductor, as we have seen, inductors and capacitor storage element, they will store the energy, and whatever the energy stored by the inductor and capacitor, they can deliver to the network up to they get completely discharged. Up to they get completely discharged. Until they get completely discharged, they will deliver energy. How much time will takes the inductor capacitor for discharge? We used to say practically inductor capacitor will take a time of 5 time constant for the complete discharge. So here what I can say now here from this, so at t is equal to 0, this is at t is equal to 0 with this switching action. Now this I can call this as t is equal to 0 minus, and this I can call it as what? T is equal to 0 plus. And here you did one switching action, then what happens now? Until you disturb one more thing, until you did one more switching action, the same thing will continues. But here you did one switching action, we did not. So again the network will be transient state, and this transient state will continue how much time? Up to how much time it is? This much of time I can say as what now? 5 time constant, and this is what? Transient situation. This is what? Transient state now. Yes, in transient state the capacitor will behave as what? Inductor will behave as what? Capacitor is shorted and inductor is open. This thing we did. So now you see this thing here, and up to this 5 time constant only inductor and capacitor will complete discharge. After that, and there is no energy for this network here, then how this network will appear after 5 time constant we can say? Yes, so here this is the inductor here, and this inductor will have energy until if they has energy they will deliver, and but this energy will lies up to how much time I can say? This 5 time constant time only now. After 5 time constant it will be completely discharged now. So the no energy after 5 time constant, but I need what now? Where I need the current now here? Yes, at t is equal to infinity means what? Then how much I can say? IL of infinity 0. How much the IL of infinity? 0, isn't it? Now see this thing here, I can use this all the terms in the formula. So tell me this expression, what I can say now, this expression for I of t, IL of t is what I can say, final value. Final value, what the final value is a 0 plus initial value. How much this initial value is a, that is IL of 0 plus na, that is 2. Yes, 2 minus 0 into what, e power minus t by tau. What is tau? Is a time constant, which is given as what, it is a L by R. The time constant is nothing but the discharging path or charging path. In this case, inductor is what happening now here, charging or discharging. If we give the energy, it will charge. For the time taken for the inductor or capacitor to charge completely is 5 time constant, and time taken to discharge also 5 time constant. Within 5 time constant, inductor or capacitor will completely get discharged, isn't it? So what we can say now here from this what we can say, and after 5 time constant, with tau is always we should call it as a the discharging time constant or the charging time constant. We will say charging time constant or the discharging time constant. Yes, tau is equal to L by R. So L value and R value we need to see now. In this path only the inductor is discharging or not? In this path the energy is discharging like this, in this path, isn't it? This path we need to see. How much is L value? Yes, tau, which is equal to L is how much in the problem? That is 4 by R value, how much it is? 20. So how much it is? 1 by 5 now. So this is 1 by 5. Yes, that means the complete, the IL of t finally it will becomes what now? 2 into e power minus 5t. 2 into e power minus 5t. What this is the? This is the current through the inductor when for any value for all t greater than 0. Right. Understood this thing? All of you. This is what will get, this value is 2 into e power minus 5t. Just see the analysis now. Just first at t is equal to 0 we have seen, what the situation of a switch we have seen, and before what happens. We need to do always for the transient problem, we need to see